Welcome back to video number 2 on gram-to-gram stoichiometry. This is the second example in your slides. We will be looking at how many grams of copper 2 chloride are needed to react with 125 grams of aluminum. So following the steps that I outlined in the previous video, the first thing that we need to do is we need to write and balance a chemical equation. So our balanced chemical equation has 2 moles of aluminum for every 3 moles of copper 2 chloride. It will produce 3 moles of copper and 2 moles of aluminum chloride. Always our first step is to write and balance our chemical equation. Next, we are going to write how much of our given amount we have above its formula in the equation. And we will write a question mark with the sought units, or what we're looking for, above the other formula in the equation. Copper, metal, and aluminum chloride are not involved in this calculation. They are not a part of this calculation at all. We're only looking at aluminum and copper 2 chloride. So, to begin, I always start with the given value. So I'm going to start with that 125 grams of aluminum to begin my calculation. It's the only piece that I was given to start with. There's really no other place that you can begin. So now we need to look at the calculation setup. So, excuse me, I'm sorry. First thing we're going to do is we're going to convert to moles because we don't have moles already. Okay, our 125 grams was what we were given. Because it isn't moles, we must convert it to moles. So to do that, we're going to use the molar mass of aluminum from the periodic table. So I begin with 125 grams, and I'm going to use the molar mass of aluminum, which is 26.98, okay, to cancel out the grams of aluminum. So what I'm canceling goes on bottom, what I'm wanting goes on top, and that is the moles of aluminum. That's what I wanted. So we have canceled our grams of aluminum chloride. The next thing that we want to do is use our mole-mole ratio to convert from what I have, moles of aluminum, to what I want, moles of copper 2 chloride. So this is where we use our mole-to-mole ratio. What I have will go on bottom to cancel moles of aluminum. What I want, moles of copper 2 chloride, goes on top. And again, what I'm canceling goes on bottom, moles of aluminum cancel, and I'm left with only the moles of copper chloride. And this is what I want in order to go on to the next and final step. So far, we have canceled grams of aluminum by using the molar mass and converting to moles. We have canceled moles of aluminum by using the mole-to-mole ratio from our equation. 2 moles of aluminum on bottom to cancel to 3 moles of copper chloride on top. This is what I want. Finally, we were asked to go all the way to grams, and so our final step is to convert moles of copper chloride to grams of copper chloride. So, moles of copper chloride go on bottom to cancel, and 134.45 grams of copper 2 chloride go on top. This is the molar mass of copper 2 chloride from your periodic table. If you add the mass of 1 copper and 2 chlorine, it equals 134.45. So to finish up, I simply calculate. I multiply my numbers from the top in one set of parentheses, 125 times 3 times 134. I close that set of parentheses, divided by, I must open a new set of parentheses on the bottom to calculate the value. Calculate that on your own calculator, pause the video, and then resume the video to see if you calculated the same value I did. The answer is 934.37 grams of copper 2 chloride. The next 2 slides in the presentation are practice problems for you. So here is the first practice problem. I want you to solve it on your own. So Problem 1, how many grams of zinc are needed to react completely with 91 grams of hydrochloric acid? There is your skeletal equation. Pause the video, follow the same steps I've shown you in this video and the previous video to calculate an answer. Then resume the video and check your work. First step was to balance our chemical equation. 1 mole of zinc reacts with 2 moles of hydrochloric acid to give me 1 mole of hydrogen gas and 1 mole of zinc chloride. I started with 91 grams of hydrochloric acid and I wanted to know how many grams of zinc that would form. As always, I started with what I had in the problem, 91 grams of hydrochloric acid. My next step was to cancel grams of hydrochloric acid. Grams of hydrochloric acid cancel here. That converts to moles. Sorry, I was just trying a new little tool. Grams cancel to convert to moles. I use my mole-mole ratio, 2 moles of hydrochloric acid. This is what I have. It goes on bottom to cancel. 1 mole of zinc is what I want. It goes on top. Final step, I cancel moles of zinc and I convert to grams of zinc. 65.39 comes from the periodic table. To calculate, multiply everything across the top. So 91 times 1 times 65.39 divided by everything on bottom in its own set of parentheses. 36.46 times 2, close parentheses, you should get 86.1 grams of zinc. For practice problem number 2. Again, follow the same steps I've outlined in the previous examples. Your problem 2, how many grams of magnesium oxide are produced from 15 grams of oxygen? Pause the video, follow the steps, and then resume to see the answer. First step is always to balance our chemical equation. So 2 moles of magnesium react with 1 mole of oxygen to give me 2 moles of magnesium oxide. The only 2 things I'm looking at in this problem are the oxygen gas and the magnesium oxide. Magnesium is there, it is just not part of this calculation. So I am starting with 15 grams of oxygen and converting to grams of magnesium oxide. As always, we're going to start with the value that we were given. 15 grams of oxygen is my starting point. I cancel grams of oxygen by using my molar mass, 32 grams of oxygen per 1 mole. I cancel moles of oxygen by using the mole-to-mole ratio. What I have and want to cancel goes on the bottom. Moles of oxygen cancel, and I want moles of magnesium oxide, it goes on top. The final step is to cancel the moles of magnesium oxide and convert back to grams of oxygen. And that is not oxygen, that should be magnesium oxide. Sorry. So 40.31 grams of magnesium oxide. If you calculate correctly, you should get 37.8 grams of magnesium oxide. As always, if you have questions, please email me. You have a set of practice problems on your note page. Please complete those. There's an online quiz for you to practice and an additional set of practice problems for your assessment. Thank you, and again, reach out if you have questions.